Good morning. I'm Devasena. In this lecture, we are going to discuss about classic TCP improvements. In that, the indirect TCP topic we are going to discuss. This topic is present in the subject wireless networks.
Classical TCP improvements. Based on unique problems associated with the mobile nodes, a set of solutions have been developed. They are Indirect TCP, Snooping TCP, and Mobile TCP. In this lecture, we are going to discuss about Indirect TCP in detail. Let us see the lecture.
Indirect TCP, that is I-TCP. Indirect TCP method has been developed based on two premises. TCP performs poorly together with wireless links. TCP within the fixed network cannot be changed. Indirect TCP representation is shown below. This is the indirect TCP diagram representation. In the further slides, we are going to discuss this topic. Indirect TCP, standard TCP part and wireless TCP part. I-TCP segments a TCP connection to a mobile device into a fixed part and a wireless part. In this, the standard TCP is connected between fixed host and the foreign agent, that is the access point, whereas the wireless TCP is connected between the access point and the mobile host. Indirect TCP segments a TCP connection into two parts. Let us see the diagram representation. This is the access point. This access point is connected to the standard TCP part as well as to the wireless TCP part. That is, the indirect TCP has two portions. One is the standard TCP portion and the another one is the wireless TCP portion. These two portions are linked through the access point, that is the foreign agent. This is represented here. Let us see the standard TCP part in the indirect TCP. Standard TCP is used between the fixed computer and the access point. No computer in the internet recognizes any changes in TCP. Instead of mobile host, the access point now terminates the standard TCP connection, acting as a proxy. This means that the access point is now seen as the mobile host for the fixed host and as the fixed host for the mobile host. Between the access point and the mobile host, a special TCP adapted to wireless links is used. However, changing TCP for the wireless link is not a requirement. A suitable place for segmenting the connection is at the foreign agent, as it not only controls the mobility of the mobile host anyway and can also hand over the connection to the next foreign agent when the mobile host moves on. The foreign agent acts as a proxy and releases all data in both directions. If correspondent host, that is CH, sends a packet to the mobile host, that is MH, the foreign agent FA acknowledges it and forwards it to the MH. MH acknowledges on successful reception, but this is only used by foreign agent, that is FA. If a packet is lost on the wireless link, CH, that is the correspondent host, does not observe it and foreign agent FA tries to retransmit it locally to maintain reliable data transport. If the MH sends a packet, the FA acknowledges it and forwards it to the CH. If the packet is lost on the wireless link, the mobile hosts notice this much faster due to the lower round trip time, and they can directly retransmit the packet. Packet loss in the wired network is now handled by the foreign agent. I-TCP requires several actions as soon as a handover takes place. The access point acts as a proxy buffering packets for retransmission. As shown in this figure, socket and state migration after handover of the mobile host. The access point acts as a proxy buffering packets for retransmission. After handover, the old proxy must forward buffered data to the new proxy because it has already acknowledged the data. And this is indicated in this diagram. During handover, the buffered packets as well as the system state, that is the packet sequence number, acknowledgements, ports, etc. must migrate to the new agent. No new connection may be established for the mobile host, and the corresponding host must not see any changes in the connection state. Packet delivery in I-TCP representation is shown below. Here we are having mobile terminal, foreign agent, correspondent node. In between that, packets is being delivered. This is indicated here. Advantages of I-TCP. No changes in the fixed network necessary. No changes for the hosts necessary. All current optimization to TCP will work. Simple to control. Mobile TCP is used only for one hop between, example, a foreign agent and mobile host. Transmission errors on the wireless link do not propagate into the fixed network. Therefore, a very fast retransmission of packets is possible. The short delay on the mobile hop is known. It is easy to use different protocols for wired and wireless networks. It is always dangerous to introduce new mechanisms in a huge network without knowing exactly how they behave. New optimizations can be tested at the last hop without jeopardizing the stability of the internet. Disadvantages of I-TCP. Loss of end-to-end semantics. That is, an acknowledgement to a sender no longer means that a receiver really has received a packet. Foreign agents might crash. Higher latency possible. Due to buffering of data within the foreign agent and forwarding to a new foreign agent. Security issue. The foreign agent must be trusted entity. So far we have discussed about the indirect TCP. Now, with the help of a small analogy, we are going to discuss the topic so far we have discussed. Just imagine that a farmer is manufacturing or producing food in the land. Now, the farmer is giving the manufactured food crops to the merchant. Now, the consumers buying the manufactured food or other materials from the merchant. This scenario, how we are going to interrupt with the topic, indirect TCP. Let us discuss. Here, the standard TCP portion in the indirect TCP is analogous to, this is our standard TCP. The standard TCP is analogous to the farmer cultivating the food materials or crops in the land. Both the functions are analogous, that we have to know. The access point in the I-TCP is analogous to the farmer hand over the cultivated products to the merchant. Here, the merchant is acting as a bridge between the farmer and the consumer. The same way, the foreign agent or the access point is acting as a bridge between the standard TCP as well as to the wireless TCP portion. Wireless TCP portion is analogous to the consumer buying the food crops or manufactured food materials from the merchant. This is indicated here. That is, the wireless TCP is directly having the connection between the access point only, not to the standard TCP. Here, the access point is acting as a bridge between the wireless TCP portion as well as to the standard TCP portion. That is why the name indirect TCP arrives. Is it clear?
Thank you very much for listening this lecture. For further updates, kindly subscribe this channel. If you like this video means you can share this video to your friends.